Welcome to this explainer. Today, we're zeroing in on an absolutely critical phase before any massive piece of marine machinery ever leaves the factory floor. We're talking about the factory paperwork and exactly what kind of testing a generator undergoes. Look, if you want to guarantee reliability out at sea, you really need to know exactly which tests your machine was subjected to and, well, what the resulting documentation actually means. So, to kick things off, let me just ask you this. Do all generators get the exact same tests before they roll off the assembly line? It's actually a super common misconception that every single machine is treated equally and run through the exact same ringer. But in the high-stakes world of high-capacity marine engineering, that is absolutely not the case. No way. All right, let's dive into how this actually works. The whole testing suite operates on a pretty rigid three-tier system. Think of it like a cascading checklist that dictates your required documentation. So first up, you've got routine tests, which apply to every single machine. Second, type tests applied just to the first machine in a new series. And third, special tests, which are performed strictly on request. Knowing which of these three tiers applies to your specific unit tells you exactly what paperwork should exist before it ever ships. Starting with Tier 1 routine tests. This is your unavoidable baseline. Now, I really want to highlight this number, 11. When it comes to routine tests, there are absolutely zero exceptions. Whether a generator is the very first one built or, the 50th identical unit off the line, it's going to undergo this exact tier of testing to verify its individual manufacturing quality. There are 11 core routine checks every single machine faces on the test bay before getting the green light. Let's just run through these real quick. It kicks off with the physical basics, so visual inspections, air gap measurements, and cold insulation and winding resistance checks. Then we hit the functional gauntlet, space heater checks, bearing runs, and vibration monitoring. And finally, the electrical milestones. We're testing the no-load point, the short circuit point, running high voltage tests, and doing excitation cubicle checks, passing all these proofs that this specific piece of hardware was, that it was physically built right.
Moving right along to Tier 2, type tests, where we validate the architecture.
Now, what's really interesting here is the core philosophy behind this tier. A type test is a highly rigorous set of tests, but it's applied only to the first machine of a series. Its entire purpose is to prove the underlying design itself, not just that particular unit. It essentially answers the big question: does this engineering blueprint actually work the way we calculated it would? Because it's proving the actual design, this is a seriously grueling gauntlet. That first-of-series machine is subjected to moment of inertia testing, no-load and short-circuit curve mapping, and, crucially, a massive heat-run temperature rise test to push its absolute thermal limits under IEC 34-1 standards. Finally, precise losses and efficiency measurements are taken. It's the ultimate first-of-series design proof. And this brilliantly illustrates the stark contrast between the two. Routine tests catch manufacturing defects on every single unit. Type tests, on the other hand, prove the engineering concept on the very first unit of a design series. It's a categorical difference, and it completely defines your factory paperwork and what data you ultimately walk away with. So let's actually test that logic with a quick real-world scenario. Imagine a shipyard orders the fifth identical generator in a given series. Does this fifth unit need a full IEC 34-1 heat run test again? Take a second and think about the rules we just laid out. The incredibly satisfying answer is no. Unit 5 gets routine tests only, since the type tests, including that massive heat run we talked about, prove the core design itself on Unit 1, Unit 5 absolutely does not require a repeat. It just needs those 11 routine checks to make sure it was physically bolted and wired together correctly. So, the crucial point here, and if you remember nothing else from this explainer, remember this rule of thumb. Type tests apply once per design, while routine tests apply to every unit. That perfectly summarizes what we've conquered regarding these two mandatory test tiers. But what happens when the standard rulebook just isn't enough? When you suspect a hidden flaw, like maybe a shaft voltage issue, or you need sudden short-circuit data that those mandatory tiers simply don't cover. Knowing your baseline tests is really just the beginning. Knowing how to push beyond them is what separates good engineering from bulletproof reliability. We are going to uncover those special tests in Part 2. So what exactly demands a special test in the real world? Stick around and we'll dive into that next time.